Hello class 11. Today's topic is more of concept based. Okay, it is a very conceptual topic, whatever we are going to discuss today. Alright, so be very attentive and pay attention to whatever your physics teacher says. Okay, so before we actually jump into our actual topic, let me tell you or introduce you to inertial frame of reference and non-inertial frame of reference. Now basically, what is a frame of reference? A frame of reference is a point from where you observe things happening. So to say, it is a point of observation. Okay, a train is running, all right, on a train is running on a parallel track, and I'm watching the train move from the platform. Okay, so the platform is the point where I'm standing on the platform is my point of reference, or so to say, my reference frame. Likewise, a person inside the train looks at me standing on the platform. The person inside the train will obviously, inside the moving train, will obviously not see me at rest. If the train is moving in this direction and I'm standing over here, the train is moving in this direction, this person inside the train will see me move in this direction. Alright? Will see me move in this direction, of course. So I am not at rest for the person inside the train. Okay? So the person inside the train, so to say, is in a different frame of reference. His point of observation is different. So do remember, frame of reference basically means point of observation, a point, a place from where you observe things happening. Now, basically there are two kinds of reference frames. One is called inertial frame of reference. An inertial frame of reference is a frame of reference which is not accelerating, remember. Now when we say not accelerating, what we mean is either the frame is at rest, either the frame of reference is at rest, or the frame of reference is moving with a uniform velocity. Okay, uniform velocity meaning, of course, in a straight line with the same speed. So that would also be an inertial frame. So the person, so to say, when I'm standing, the person is me, of course, when I'm standing on the platform and I'm looking at the trains, different trains go here and there in different directions. So I am, so to say, in an inertial frame of reference because my point of reference is actually at rest, not accelerating. Whereas the person inside the moving train, the train is accelerating, the person inside the moving train and looking at me, that person is in a different frame of reference, like I already mentioned, and to be more specific, he is in an accelerating frame of reference, which is called a non-inertial frame of reference. Okay, so accelerating frame of reference, it's called non-inertial frame, whereas non-accelerating frame of reference, it's called an inertial frame of reference. Remember that. Now, what are the things that are true for these frame of references? Newton's laws of motion is totally valid in an inertial frame of reference. Also, there is no question whatsoever of something called a pseudo force coming into play whenever we observe from what is this thing called? Yeah, inertial frame of reference. There is no question of something called a pseudo force. We'll talk about this thing, pseudo force, more. Okay? Now, in a non-inertial frame of reference, what happens is Newton's laws of motion, it's not valid. Okay, so for an observer in a non-inertial frame of reference, Newton's laws of motion is not valid. Remember that. And of course, in non-inertial frame of reference, or so to say, in accelerating frame of reference, we have pseudo force coming into play. Alright, so do remember these points for inertial frame of reference and non-inertial frame of reference. You can pause the video and of course copy these things. So I'm going to erase this, and then what we are going to talk about is something called, a very important thing actually, very important for you all, pseudo force. let me write some things about this force first, okay? Pseudo force, also called fictitious force, not real, which means, of course, okay, fictitious force, fictitious force. Alright, so let me write, first point is, of course, not a real force. Now, in what sense are we saying pseudo force is not a real force? We are saying pseudo force is not a real force because as it does not arise. I think this word would be better. As it does not arise due to mutual interaction between bodies, two or more bodies, okay? Now this is not a real force like I've written, in the sense that it does not arise or it does not come into play due to mutual interaction between bodies. Now how do forces originate? There has to be some kind of interaction between two or more bodies, because of which forces, something called forces or real forces, so to say, come into play. Like when I hit the wall, the board, okay, there is mutual interaction between my hand and the wall or the board. You know, there could be electromagnetic interaction between two charges. There can be magnetic interaction, two magnets repelling each other or attracting each other. Okay, so there is interaction between the two magnets, two bodies. Force of gravity is pulling this. So there is, interaction between the earth and this piece of chalk. Alright, so forces arises due to mutual interaction between bodies, whereas pseudo force comes into play without any interaction between bodies. There is no interaction of any kind between bodies, and anyhow what happens is, to a person in a non-inertial frame of reference, this pseudo force acts. Okay, so since it is not a real force, it does not act in pairs. So to say, Newton's third law of motion tells us that whenever a force acts, if we call that the action, there has to be a reaction for it. So to say, forces always act in pairs. I had spoken about this when I discussed Newton's third law of motion also with you all. So there is no action and reaction pair, so to say, in case of pseudo forces. Therefore, they are fake forces, remember. If you call this action, there is no reaction whatsoever for it. But instead of these things being true, it feels or appears real for an observer, whoever the observer is. It could be a person, it could be an insect, okay, it could be whatever kind of an animal. It feels or appears real for an observer in a non-inertial frame of reference. Although it may be a fake force, although it may be an illusionary force, so to say, but still it feels or appears real for an observer in a non-inertial frame of reference. Okay, like you are inside a car, in a bus, say for example, okay, and the bus is moving in a curve with quite a velocity, quite a speed, okay, so it is turning. So what happens to our body? Our body, we feel as if our body is being pushed in the outward direction like this. Okay, as the car or the bus is taking the turn, our upper part of the body is being pushed like this, outside, towards the direction which is radially outward of the curve that our bus is describing. Alright, so what is that? That is actually a centrifugal force that we are experiencing, and mind you, centrifugal force is a pseudo force, and actually centrifugal force is the topic of our day for this video. Okay, but before we jump into what is that centrifugal force, let me rather give you some examples of pseudo forces. Like, we get pushed against the backrest of a seat inside an accelerating car or bus or an aeroplane, whatever. Okay, accelerating car. You must have noticed, whenever you're inside a car and the car starts accelerating, what happens is your body, the upper part of the body, gets pushed backwards against the backrest of the seat. Okay, now that also is a pseudo force. What else? So this is one example. You can copy this, and because I want to erase it, of course. So you can pause the video and copy this, because I want to discuss about some other examples also. The other example that we can give is, again, you are inside a car. So this is your car. Okay, and the car is moving in this direction. A is the acceleration. Okay, let me not write this for now. So the car is moving in this direction, and inside this car, what you have is, you have a simple pendulum, alright, which is suspended, a bob that is suspended from a string, a massless, inextensible string, so to say, and whose upper end is fixed to the roof of the car. Now, your car starts accelerating, and you are inside the car. You are inside the car. Sorry for my pictures, okay, class 11. I draw these kind of pictures only. Okay, this is the best that I can do. So, now you're inside this car, and the car is accelerating. But get one thing very, very clearly. The car is accelerating for an observer who's outside the car, who's watching the car move from the outside. The person is standing and he's looking at the car moving. So this person, so to say, is in an inertial frame of reference, mind you, whereas your car, I'm seeing, is accelerating. So say this is me. Okay, so I am the observer in the inertial frame outside the car, standing at rest on the ground and looking at you. Okay, so with respect to me, for me, the car is accelerating. I see the car accelerating. I see you accelerating. I see the simple pendulum accelerating. Alright? So I know that you are accelerating. But you inside the car, you are in a non-inertial frame of reference. Because you are actually accelerating. But you don't know that you are accelerating. Alright? So what happens is, you look at this pendulum, what you see is, initially say the car is at rest, initially the car is at rest, for me also the car is at rest, for you also the car is at rest, so the pendulum is hanging like this, nice and easy. But the moment the car starts accelerating, I see the car is accelerating, you don't know the car is accelerating. Alright, you don't know the car has started moving. Alright, now what you therefore see happening to this pendulum is, you see the pendulum comes in this direction as if some kind of a force has acted on it. Alright, and all the while in the process of I see the car moving, so all the while that I see your car moving, you will see that your pendulum is like this, in this very position, and you are shocked to see that happening. You don't know what made this pendulum move in this particular direction. Okay, now you might ask me, sir, I'm inside a car and I know when the car is accelerating. Okay, because I see the trees and the houses outside, they move in the backward direction. The faster and faster the trees and the houses outside, it starts moving in the opposite direction. So I know we are accelerating. So you might ask me that question, and you are saying, sir, that you don't know that we are accelerating. So you might ask me that question, and you are absolutely correct. We can tell that we are inside a car, and we can actually tell when we are accelerating. But that is from experience, remember. So we know when we look at the trees and the houses outside, and the faster the houses and the cars moves in the opposite direction, we can tell we are accelerating. But here, if say you are moving in an infinite void, dark space with no point of observation whatsoever, you don't see a tree, you don't see a house, you don't see a small pebble, you don't see anything outside there. Okay, and your what do I say, spaceship is actually accelerating, it's actually moving. But you will, in that case, you won't be able to say whether your spaceship is accelerating. Forget about accelerating, you won't be able to say whether your spaceship is moving or not in the first case. Alright, and you have a pendulum, okay? So you don't know whether you are accelerating or not. You have a pendulum and you see a pendulum moving in this way. All the while your pendulum is like this. So obviously you will be shocked, as if some kind of a magic has happened, and as if someone is pushing, or ghost is pushing, alright, the ball over here, the pendulum in this direction. Alright, so there is, so to say, for you some kind of a force acting. But for the observer outside, if there's an observer in an inertial frame, okay, the observer outside can actually explain what is the thing happening. For you, again, coming back to you, in a non-inertial frame of reference, you can only explain this phenomenon happening, the pendulum moving, only if you consider a fictitious force, a pseudo force, okay, that has pushed. A pseudo force acts on this pendulum, because of which the pendulum moves in this direction. So for you to prove this happening, for you in a non-inertial frame to prove this happening, you have to consider a fictitious force, a pseudo force. Whereas the observer outside can nicely explain the phenomenon that is happening without considering any fictitious force. What will the observer in an inertial frame see? The person in the inertial frame will also see this happening. But for him, when your spaceship was not moving, the forces acting on this pendulum was mg, the force of gravity, and of course the force of tension. But once the car starts moving, what I will observe is, okay, me, the observer in the inertial frame, what I will see is, I will see the car moving, of course, I will see you moving. Then I will understand, okay, this bob of the pendulum was in rest initially when the car was not moving. Now when the car moves, the bob has inertia of rest, so to say. So the bob wants to continue in the state of rest, so it moves in this direction. Because it wants to continue, it wants to remain in the state of rest. But when it moves here, when it wants to remain in the state of rest, although the car has moved a bit further ahead, the force of tension again in this direction acts, because this part of the wire is moving along with the car. Alright, so for me therefore, once the car starts moving, the bob moves backward, and then after, the force of tension nicely goes on pulling the simple pendulum in the forward direction also. So then after, I will also see the simple pendulum or the bob itself accelerating with the same acceleration. I will see the car, yourself, and the pendulum accelerating with the same value of acceleration. Okay, so for me, what is now the total force acting on the pendulum? It is the force of tension plus mg, which is providing m into a, the acceleration that this pendulum is experiencing. This is what I will say. Okay, so for me, there is no question whatsoever of a centrifugal force acting. But you, since you don't know that you are accelerating here, alright, so for you to prove this phenomenon happening, you have to consider a pseudo force. You have to bring the concept of pseudo force into play. Okay, so this is another example of pseudo force, a lengthy story, it became for the simple pendulum. And the third kind of, let me erase this, okay, so the third kind of pseudo force is the topic actually of the day, which is centrifugal force.